Hey everyone, it's 10 o'clock on a Thursday. Well done to everybody. Can you, bear with me. Send chat to everyone in meeting. We've started. Can you say here and answer the following questions? Dig out the email now and copy and paste it. So bear with me. Sent. Shit. Folders. Sent. Can everybody hear me okay as well? Yes, excellent. You can hear me. Perfect. So, if I miss anybody on the letting in the room, shout out in the chat and I'll let them in, because sometimes when I get started, it's difficult to keep an eye on that at the same time. And can you answer all the questions? What device you've got, whether it's a PC or a laptop or a phone, and whether you've got 3G, slow broadband and fast broadband. Is that everybody? Kiva, is anybody coming in extra? Tiffany, Kana, Kiva, Katie, Kana, Juma, Ina. I think that's all that's here at the moment. So we've only got, I'll let some may be coming later. 1, 2, 3, 4, 5, 6, 7. I'm going to unmute you for a moment, okay? So let me turn off the mutes. Unmute, 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 unmute. Right, I can hear you as well now, all of you. Right, there you are on the screen as well. Perfect. And what we've got is okay, Yanni, Tiffany, Connor, Ina, Kiva. Is there anything anybody would like to ask me about what the hell is going on at the moment? And I'll see if I can give you an update. Anybody got any questions, either through the voice, or you could raise a hand, or you could do a chat. Is there anybody, any questions about what the hell we're doing? Any questions, Connor? Jing is come. Welcome, Jing. And I'm going to unmute. Oh, there we go. There we go. You can all talk now as well. So, any questions? You can put it in the chat. You can ask me what you think is going to happen. Any questions whatsoever?
What do you think is going to happen with the end of the semester handle?
Well, even though I said I could answer, I haven't got the answer. But there are obviously worked it out that there are different scenarios. Technically, you don't graduate until November. So I think the college is looking at different ways of structuring a smaller design project if it wants to do it before November, or there's a lot of options, I think. But at the moment, the goal is to keep going with the design project, keep going with the work that you have to do, and we are here to giving the lectures as well. So that's where we're at. Whether we have a 4-week thing later, or we do it based on the thing now, it's up in the air. At the moment, we haven't had guidance from the department or the other schools or the RIBA about what we should do. So that's where we're at. Keep going. Is everybody healthy, and is everybody looking after themselves and getting on okay?
Yeah.
Good. What I'm going to do then is I'm going to start with you would have received emails from the president of IT Sligo about looking after yourself. I'm going to go over that again now about what you can do to get through this process, look after yourselves, stay healthy, and what you need to do. So I'm going to mute you all now. And then what I'm going to do is, admit Lucy. Sorry, Lucy, I didn't see you there. I'm going to mute you now, and then I'm going to go over to PowerPoint and start the presentation of looking after yourselves. So here we go. I go to share screen. Hang on, I've got to do one thing first. PowerPoint, slideshow. Setup show. Please bear with me. Presented by an individual. Okay. Here we go. Try. Share screen, and it is that one. Share. Can you all now see a PowerPoint presentation on your screen? You give me a quick thumbs up. Perfect. You can see that. Perfect. Good. Right. So this came from, funny enough, because I actually saw this link before the president gave it, but this is the print. This is the link. This is where it came from. And what I'm going to do now is start the slideshow. Start. So you should now see the slideshow. Perfect. So this is the link that it came from. So what we need to do to survive this process is we need to be very fluid in our thinking. We need to be very adaptable and be able to change our thoughts and our processes and our routines quite quickly. So we need to be fluid, and we need to be adapt daily. Me as an employer now, as well as working, I am constantly looking and changing the revenue guidelines for tax and all that stuff for the employees that I've got. And it's been a real struggle. There's two real struggles. One has been the employees, and two has been the, oh, sorry, Leanne. Hold on, let me get Leanne as well. Sorry, apologies, Leanne, I didn't see you up there. I'll keep it up there now. And the other thing has been these IT Sligo meetings. We spent like hours discussing on teaching. It's been difficult. So you need to be fluid in your thinking. You're going to feel upset, just absorb it, feel it, and then move on. And that's the only way of surviving this. Let me go back to PowerPoint, sorry. So we need to be fluid in our actions. So it's good to have a structure for your day, but the fluidity means that you also need to be flexible if the plan goes astray. If things don't go right or go wrong, then you need to be fluid in your thoughts to be able to adapt, and you need to be fluid in your actions to be able to change. But a routine is good. So get yourselves into a good routine. And if you don't feel like doing loads of stuff, learning a new language or whatever the shit you're meant to be doing, don't do it. You're meant to be we are now in survival mode. So don't overwhelm yourself with things to do. Don't feel as if you have to do loads of busy. Or, to be honest, your course now is a, bear with me, I've got a thing here, message. Sorry, no, that's not it. Yeah, your course now, just try and get through it. We're all trying to get through it as best we can. So just do your best. If your 3G is bad or you haven't got a printer, we just work with it. Don't get upset over it. Don't get upset. Don't get stressed. We're going to work these things through, and we're going to try and get every single person that we can over the line here to get your degree and get sorted out with our IBA accreditation. So you don't need to be perfect. Same thing as the fluidity of thought and what you're doing during the day. Then you don't need to be perfect. So be easy on yourself. And if you can't get something done, don't worry about it. Do the things that you can do. Just keep going. Just keep going. That's the only thing that you can do. And you don't have to be perfect. And your work that you do doesn't have to be perfect. So I'm definitely not asking for perfection. So we need to keep it simple in that we need to set the bar really low, in that we don't need to be doing loads of stuff. We don't need to be perfect. We're now in survival mode. We're going to keep it really, really simple, and keep your life simple, and don't over complex or overthink things. So these are other advices I saw as we just move that over a bit there. And okay, so you should now be working from home completely. You shouldn't be going out all the time. You shouldn't be socializing. Just try and connect with people on Facebook and on Twitter or whatever, or Snapchat or TikTok. And what you should do is be getting into a good routine, eat healthily, get some sleep, and schedule time in for that eating and sleeping. Otherwise, you're going to get sick. Even if it's not the coronavirus, there's a lot of other shit going around making people sick at the moment as well. And that's that's throwing everybody out. They're getting sick. They're getting stressed. When the stress makes them more sick, and then they're thinking they've got this virus. So the chances are, if you do get sick, you haven't got it anyway. So look after yourselves. So we need to keep fit. The government has allowed you to go out for a walk or a cycle for one thing during the day. So there's lots of indoor things. I've got an indoor bike set up ready for me to put some cycling on the TV and cycle along well. So you need to keep fit. So don't beat yourself up if you can't get out one day or whatever, but try and get out. Try and do some exercise. Get yourself fit. And mindfulness is good. There's some stuff on, I haven't listened to it, but the link here was Dermot and Dave on Today FM, dermotwhelan.com, start-meditating, and do some stuff that you like doing. Listen to music, watch the TV, go through basic stuff, simple stuff. Try and get some college work done, but don't beat yourself up if you can't do it. And there's lots of people out there that will help. And I'm connecting with people that remember Craig. I'm going to connect with him using Zoom later as well. And if you're on Twitter or Facebook and that, anybody that's negative, stay away from them. So we need to surround ourselves with positivity. Otherwise, what's the point? So we need to be positive and don't let anybody affect negatively our mood. So that's the online groups. So manage your anxiety. If you're getting anxious, meditate, go through the mindfulness, and talk to others about how you feel, and see if you can help others out rather than concentrating on yourself. So try and help others out, and you don't have to be strong all the time. So it's okay not to feel okay, and it's absolutely okay to ask for help. And these are some of the images that the president put up, and this is going to be you saving a lot of other people. And we're all in this together. So this is the link. I'm going to put the slides up later. If you do need to see the student counselling service, email them with your, we're not going to see them, we're going to probably speak to somebody on the phone. Email them your name, your contact number, and your student ID to this email address, or you can visit www.itsligo.ie/student-hub for more information. So I'm going to leave the slide, I'm going to put the slides up later. They're not up yet. I'm going to try and I'll put them on my site and also put them onto Moodle as well later. So here we go. We've got some slides that we're going to get started. Everybody still see the slide, traditional buildings, structures and energy. Everybody still see that, okay? We aren't seeing the slideshow moving. Stuck on first page. Shit. Can you see traditional buildings? Right, okay, I'm gonna do it. Let me check again. Sorry, I'm gonna stop that. Okay, back to me again. Share the screen. Microsoft PowerPoint. Hold on, let's get back out. Okay, I'm saying it privately to fucking hell. Everyone in the meeting, okay. Can you see fluid in thinking? Think. No. Right, hold on. Let me, hold on. Right, it's back to me again. No, okay. Bear with me. Test, Microsoft PowerPoint, share. We quit out. I'm gonna quit out of. Right. Hold on. Bear with me. PowerPoint. Quit PowerPoint. Right. Bear with me. We're nearly there. Okay. Hold on. Zoom. Share screen. Microsoft PowerPoint. Share. Can you see? Keep it simple. Yes, we're in business. Yay. Right. Okay. Now I'm gonna have to go back to the beginning now because let's leave it in. Let's leave it on the actual PowerPoint. Okay, rather than doing the slideshow. So what's funny now? I'm gonna have to go through that again. I'll be honest, it was a bit emotional reading it out for me, but this time I'm probably going to be less emotional. Okay, so that's the can you see the link there that this came from journal.ie? Can you see that link? Good. Okay. Right. Then we've got. So this is what we've got to do. Okay. So we need to be fluid in our thinking. That we need to be very adaptable in our daily changes and the things that are changing around us, and everything that's happening requires us to be able to move and change our thoughts very quickly. It's going to be a roller coaster, staying on your own and going through this. So the first thing you need to do is be fluid in your thinking. So everybody can see fluid in our thinking. Okay. The second thing is that we need to be fluid in our actions, in that when you have a nice, simple routine, it's good to keep a routine going, but don't feel as if you break from the routine, that you beat yourself up over it. You need to be, it's good to get into a routine, but don't feel as if you have to fill every minute of the day with stuff to do. And acknowledge that what you're doing on your course is difficult. So don't beat yourself up if you can't do something for whatever reason, whether it's the internet or the lack of a printer. Just do your best. That's all we can do. The staff are trying to get you over the line here in whatever way we can do it to finish your education off at IT Sligo, and they're doing their best. And we have to be adaptable in our thoughts and in our actions. I spent 2 hours yesterday going through stuff. So, third slide, do not be perfect. That if you can't hand something in or you can't do something, don't beat yourself up over it. Just do the best that you can. We need to keep things simple. So we're now working in effectively a war situation where you set the bar low. We're just trying to survive. We're just trying to keep these things going. So let's try and work that way. You need to be sleeping and eating well. Keep a basic timetable, but schedule time in for eating and sleeping. And you need that routine is good, but don't beat yourself up if you can't keep to that routine. Get active. The government allowed you to go for 1 walk, 1 cycle, 1 run a day. Try and keep your activity levels up. If you are not exercising, you will get more stressed and you will get more sick. Try and react to stress appropriately, where you could do some mindfulness, do some meditation, do the things that you like doing, watch some TV, put your feet up, do a puzzle, have a bath, basic stuff. Keep in touch with your friends. Keep in contact with people that are reliable, positive influence. And you don't need any negativity around you. So try and limit and keep away from people that are negative. We need to make a positive impact. Try and do your best and talk to others about how you feel. Because remember, it's okay not to feel okay. And it's absolutely okay to ask for help if you need to. These images came from the president. So this is why you're staying at home. We're going to try and save some people here. And we're all in this together. This is the slide that didn't show. Can everybody see this? Can everyone see this? This is if you need any help at IT Sligo. You email your name, contact number, and student number to studentcounsellor@itsligo.ie or visit itsligo.ie/studenthub and they can help you. So that's the slides there for trying to survive this. We're now going to work in, we're going to look at traditional buildings and structures and energy and of traditional things. So I'm going to make sure that these documents are going to be on the website. They're really good. One's from Scotland. It's the conversion of traditional buildings from the Scottish principles and practice. And there's another document on the structural renovation of traditional buildings. So if your design project includes a traditional building where you're going to renovate it, extend it, restore it, or whatever, these notes might be of help to you. So they're going to be online and you're going to be able to access all of this. I've taken out from, Kieran, sorry, I missed you. Sorry, Kieran, I missed you up on the participants. Sorry. So you haven't missed much, but the slides are going to be up. The first section was basically looking after yourself. We're just starting now the main slides. So I've taken out some images from these documents, and we're just going to discuss them a little bit. We can open it up a little bit in the chat as well for Ina admit. There we are, Ina. Sorry. Okay. Yeah, so I've taken out some images from bear with me, just readjusting my screens. That's better. Okay. I've taken some images out that I think are really, really cool ones, so that we'll discuss them and go through them. So this is the first one here. So this would be a traditional building, and we've gone through loads of stuff about modern buildings and all the stuff relating to mechanical heat and ventilation. And this explains why it's really important to understand traditional buildings and the interventions that we're going to make in order to maintain that breathability. We've already discussed using calcitherm for interior wall insulation, and also the Isover Optima system, and that's a breathable wall. But this diagram explains why it's really important, in that what we've got here are very thick walls that can absorb water. So what the water needs to do is to be able to evaporate to the outside and also disperse and be permeable inside the building. So we need that movement of air through this. We also need air to be able to move through and through the building in order that we keep circulation of air moving here. But the problem is obviously when you've got air leakage, you're going to have heat leaving the building. So we need to balance out those two things of air tightening something, but not so much, or not having enough ventilation that there's no ventilation in the building. Traditional buildings with timber floors would also have ventilation underneath them. That's why you'll see older buildings with vents in the floor in order to provide that ventilation. And it's really important not to block those vents up if it's a timber floor. And we're going to see some slides on that in a minute as well. And chimneys and fireplaces, we're venting here. So the reason why these old buildings don't get riddled with black mold is because of that ventilation that's moving. They're not going to be warm and they're going to require a lot of heat, but that's why they weren't moldy, because the ventilation was there. So this is now a modern building where we have insulation, high levels of insulation. We've gone through all the stuff relating to internal heat gains. We've got ventilation through trickle vents in the windows, and we could have a mechanical heat and ventilation system to move air around this. So that's the difference. And if you notice between this one and this one, the walls are a lot thinner in a modern building than an older one. So you can see here, what you've got here is actually a heat sink and a heat thermal mass, because we're not getting as much thermal mass here either. So if we look down at the bottom of this detail here on a traditional building, down at this point on the traditional building, at the base of the foundation, what you'd have is, this is what's going on in that situation where you've got the wall sitting on a foundation. Sometimes they're not even proper foundations. In a lot of cases, we're doing a thatched cottage in a dare, and we're digging a trial hole to see what foundations will be there. And the chances are there's going to be none. What can happen, the stonework of the wall will just get a little bit fatter and fatter until it gets thicker at the bottom than it is at the top. That's called battering. So just going to type that there. The wall is battered. God. As it thickens around. That's really the only foundation that there is. So we're looking at investigating that. I'll let you know what the wall thickness is at that point. So what's happening here is that you've got a vent here, and that's, you see the hole where the arrow is at the bottom, just above the word damp. There's a timber floor, and the air vent is allowing that air to circulate below the floor and behind these internal surfaces. So it's allowing the air to circulate here to prevent the damp coming into the building. So if you block that up, basically what happens is the water gets in, you're getting mold here, the damp's coming up, starting to rise, and that's what causes that rising damp. In that the ventilation is critical at those junctions to stop that damp occurring. As the stone wall is really water permeable, so as the water increases up the wall, you can see the winter capillary rise here, the moisture in a band. And what you've got are two bands. One is the summer band of how the water rises, and the other is the winter band, obviously higher, because you're getting more rain in the winter. And as that band occurs, what you've got is between the winter and the summer band, you've got a space where it says salt crystallization zone on the left-hand side. So that's what you would see on the outside. It's like a white salt occurring. It's like a whiteness on buildings. And that's why you see that white band. It's because where it's crystallizing on the surface at that point. So ways in traditional buildings to move that water away from the building. One would be to keep a timber floor ventilated. And the other is here, we can see a French drain. So we're actually creating a hole here. We put in a land drain, a yellow pipe drain, to pull the water away from the foundations at that point. We wrap it's a yellow land drain. It's yellow, it's got holes in it to let the water in. We wrap that yellow pipe in a filtration fabric. It's the one I use, I think it's a TS20 filtration fabric. And the fabric allows the water in, but it doesn't allow any of the dirt in and all the muck. So above the land drain, you have a load of stones. So the water comes down, the earth can't get in, and it's pulling that water away from the wall. Water's an interesting thing in that what it does is it's looking for the biggest volume that it can get to. So that's why water comes into a house. That you've got, say if you had a crack in a cement wall here, the water as it penetrates is looking to get into that biggest volume. And the biggest volume is that room. That's why the damp is trying to get into there. It's moving into the biggest room. So if you create something here that's a pipe that's close to this, its naturally instinct is to try and get into that pipe in order to move away to the biggest volume. That's what's going on there. So a couple of weeks ago, we did sound impact. This is actually a diagram showing the same thing on a traditional building. We were trying to hear the sound through the concrete floors on IT Sligo. On a timber floor such as this, you could have an impact, and you'd have lath and plaster ceiling. You're going to hear every single knock coming here. What you can do is you can seal gaps between wall and floors. You might need fire stopping to stop fire spread through these gaps. And on this is what's happening in that sound, that you're getting sound moving behind lath and plaster. You've got impact sound through the floor. And what you can do on an existing floor is this diagram, where you have a resilient flooring system, and it goes over the top of the existing flooring, either relaying it or replacing it with plywood. You can then place in between the joists a sound deadening insulation, and that's your insulation here as well. So the steps are that you can raise the existing floorboards and replace them. You then are placing a new flooring over the top, and whilst this flooring is up, you can then place sound deadening insulation between it. But you need to take into account that if it's a protected building, then anything that's related, like all the historic things like skirtings and any architraves or dados may get affected, so you'd have to look after them and protect them. So that takes into account a traditional building of the sound insulation requirements on a traditional building, tying into the lecture 3 weeks ago, I think. We're going to have a quick look now at the history of different materials over time, so that you have an appreciation for when things started to come in and when they started to be used. So if you go out and look at a building and you can see some of these things, this diagram is going to help you through time see what period these things were introduced. So you have a chronological history of material and what age it came into the building. This is important for when you're doing conservation reports, that you can see, oh, this piece was done in the 1800s and this piece is the 1900s. So you can see here that cast iron beams were brought into somewhere around the 1800s, and they fizzled out in the sort of 1850s. Cast iron columns went right from the sort of 1800s right the way through to 1900. We are renovating Markree Castle Courtyard, and they've got cast iron columns. So that was about that time in the late 1800s. Wrought iron then came into 1840. You have mild steel coming right up, different filler joists, different bricks. Cavity walls were started in the sort of 1940s, 30s. So if you know if it's a cavity, you know it's not going to be anything earlier in the 1800s. Sand cement mortar here, softwoods all the way through. If it's a hardwood, and you need to be able to be good at spotting woods to know that some soft woods are hard, and some hardwoods are soft, so it makes it complicated. So any hardwoods would have stopped around about the structural things around about the 1800s. So the cast iron beams here, this is a diagram of typical iron beam sections. So these are typical ones that you'd see in a building site. You could have a cast iron one. If you go back here, we've got cast iron beams. That's the period that they're in. We've got cast iron, that's the shape of them. Wrought iron, they're only 8 inches, 200 mil deep. And then a wrought iron girder. I think some of these are actually in Foxford woolen mills. You see them alone in like the old mills, these type of things. So that helps you with understanding beams. These are diagrams I've taken out from the Scottish book explaining traditional axonometrics of a traditional building in a Victorian terraced house. So I'm not going to go into great detail with it, but what I'm going to do is, I know you're doing your design project at the moment with Bernie and Michael, and what I'm going to try and do is try and tie in with them to give you a list of things that we require you to do for BST that fits in with that. So dependent on what your project is, you're going to need to do an axonometric that shows the structural concept, structure, like we did in semester 1, showing the structural principles of the way your building works structurally. And I'm going to summarize all of this in an email later anyway. So that's one of the things you're going to be asked to do, is a structural concept. There was a lecture that I did when you had your rag week. Oh, such great days in the past that had structural flooring in it. I would highly advise you to, anybody that was not able to go to that lecture, to go back and see if you can understand the structural flooring lecture that I did. This is a Victorian industrial building. Again, it's naturalmetric. You can see you don't have to do it as well as this. This is used as an example showing the principal structural parts of this typical Victorian industrial building, with a list here on the left-hand side explaining the structure. And as well as the axonometric, you obviously need to draw it, but understand the structural principles of what's holding this building up. So you need to go back over your lectures for things that we did on, remember all the yoga that we did of making people stand up. We've got compression, we've got tension, and all the structural principles of how your building's going to stand up, all the way from the foundations right the way up through what the framing would be, whether it's a concrete floor, the columns that are going to support your structure, how your roof is going to be supported. Now, this was in the diagram as well, and I have a real life case study to show you here. This is to help you if you are looking at a traditional building, the types of subsidence that is caused by a foundation movement, where if the building is, the foundations are moving down, the building is moving, obviously, and what will happen is that cracks will develop in that building. These are the three principal things. I'm going to show you a case study in a moment of how a building, the foundations of the building, how they can move. So this is where the ground is moving up. It's hogging here, and these are the types of cracks that you would have. This is a tree located next to a building, and the tree's roots are going under the building. Now, it's not the roots themselves that's a problem. The roots, well, it is the roots, but it's the roots absorbing water into the tree to make it grow. So what happens is the water comes out of the sky, hits the ground, the tree roots are absorbing it. That pulls moisture away from this, and it dries out the foundations. And when it's rock hard and dry, there's nothing to hold that wall. There's a gap between the walls and the ground, and the floor, the foundations start to move and locally settle. And these are the types of cracks that you'll see. In a moment, I'm going to show you an example of that. And generally, if the ground is poor anyway, and there's it's on sort of boggy ground and the ground is sagging, these are the types of cracks that you'd see in that. So this might help you if you're ever out looking at older buildings and seeing how cracks develop. Now, this is one of my own projects where we saw a crack on the outside here, and then the owner is ringing us to say, let me get rid of this a second, bear with me. The owner is saying, there's a bloody big crack in my kitchen, and it's getting worse and worse. So I turn up, and it started with a small crack here. On the inside, the crack's getting absolutely enormous. You could put your fingers in that hole there. There's the corner of, that's the corner of the door in outside, That's the corner of the door inside. And you can see the way that that crack's moving. The whole of that extension is actually tipping like that. So it's basically what is causing that foundation to go from here and tipping like that, in order that there's the, let me see if I can get something here. There's the vertical wall. There's the extension. This is tipping. And you can see that the gap between my top finger and my phone, that's where the crack is starting to occur, down towards the easiest point where it can crack at, and that's where that window is. So we're currently going through insurance with it. I think I mentioned this project last semester, and the insurance is still ongoing. This is my personal opinion. I think insurance is a complete scam. All of that trip that I was going to in San Diego, well, the bits that I paid for, insurance won't cover it. At the moment, we're still arguing with the insurance company on this. So they're arguing, oh, you can see here, oh, it's like, oh, it's something to do with the drains. There's water coming into the drain here. And maybe down below this, there's water. And the water is causing the foundation to subside. So we had drains tested, water and all the radiators tested. And then I started thinking, oh, great. Next door's garden. This is a view from upstairs, from the kitchen, from the bathroom upstairs. There's massive bunches of trees here, loads of trees. Look at this here diagram. Remember that one? There's a tree there. I then thought, maybe these trees, they're not right next to it, but they're really close. And I thought, okay, let's go next door. This is the house next door. They've got a crack in exactly the same place in their building. What we've got is summers that are, because of the climate emergency, summers are getting hotter and hotter, and it's drying out the soil. The engineer that came out to look at the soil at the base of this foundation said it was the driest soil he'd ever seen in his life. It's absolutely like rock, bone dry. You'd think it would be great for foundations being dry, but the water, the soil has absorbed the water. It's getting smaller and smaller and smaller until it ends up like a rock. When it gets smaller, there's gaps then between where the foundations were and where the soil was, and that's caused the drop. And that's why we've got that crack there. When you look at older buildings on an end gable, you'll also see bowing of the walls of these older buildings like this, where you've got from the top to the bottom, the buildings start to bow out. You can place a line coming out and a straight line down and measure that distance for how much that wall is bowing out. And when it bows like this, the same thing's happening, it's going out. So that's going out from here. So you've got a crack from the window across to that top point, and that crack is moving all the way down through the building. Now, buildings have cracks all the time. There's settlement cracks, tiny cracks. You'll notice that cracks that are on the inside and the outside are really serious. You can see here, this was the one that was outside, and that crack's transferred to inside. So when the crack is going both inside and outside, it's serious. The bowing of this wall, you'll see ways that structural engineers have attempted to fix that problem, where they have these solutions. These are 3 solutions structurally to do that, where they can cast in a piece of concrete and have a metal rod and tie that in to pull that wall back in. You can have corners. If you look at this, if you reinforce these corners here, that would stop that wall from bowing out. That corner, if it's reinforced, would stop the wall bowing out. So that's what's doing on that second diagram. There's a reinforced corner with steel rebar in it to reinforce the corner. And you'll actually see this third one a lot in London, where you see, and probably in Dublin as well, where there's a plate and you're tying it back. So basically what you're doing is you're having a tie here to pull that wall back in. And that's what that plate does. You see it in the rod going through, tying it back in. That book that I mentioned here, I had it, yeah, Structural Renovation of Traditional Buildings. It's really good. There's loads of great details in it of all the things that I've just showed you there. It's got details of solutions such as this. Obviously, you're not a structural engineer, but you could discuss this with your structural engineer on different ways of solving problems. They've got other great details of how you repair ends of trusses. You can see here where you're splicing plates together. We actually did that in Markree Castle. We did the same thing. We've done this before as well, where we've had plywood gussets. We even do that on new jobs where you want to strengthen up a truss by having a plywood gusset nailed across the truss. I've included this because I don't know whether you know or not know this. These are so that whenever you're out, you can understand the different types of bonds that you'd have on a traditional building. So that if you were ever extending and you wanted to do a similar bond, this would be the types of bond that you'd have, where you've got, so there's headers and stretchers. You'd have header, stretcher, 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 header on the English bond. And then above that, you'd have stretcher, 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 and then they alternate. On the English garden wall bond, you've got stretcher, 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 and then you go in the opposite way with stretcher, stretcher, and go in the opposite way. Flemish bonds, it's more of a traditional bond that you would have seen. You've also got a Flemish garden bond. So that is the first section of this. We're now going to look at Enofit. Any questions? Anybody got any questions on the slides that I've shown you up to that point? Oh. We're going to be online, so you can go back over them afterwards. So what I'm going to try and do over this period from certainly like after Easter, and we're going to go through all of the modules, the BST and the professional studies. I'm going to make sure everything's got covered, and I'm going to make sure that all of the learning outcomes, I've delivered the lectures to make sure that we've got enough material to make sure I've covered the course content. And then we need to work out what work that you need to do in semester 2 in order to meet the learning outcomes that can be assessed. So that hasn't been done yet, and that's what's going to happen. So this is the next section of this lecture, is Enofit. And it's a bit technical. This is the book that this information has come out of, and James Traynor wrote it. I probably wouldn't, if you like technical stuff on Enofit, and I'll explain what Enofit is in a moment, that, actually I'm missing a slide there, that's annoying. I'm missing a slide, I can hold it up to you, I can read it out. Enofit, so it's a bit technical, it is very, very technical, and it goes through stuff. I got a load of free books over the last year. I picked out the ones that I wanted because here we are. You can't see it there, but my name's in there as a credit for helping him out, proofreading it for him. So what is Enofit? So this lecture I'm giving now is the principles of how to renovate existing buildings to the passive house standard. So what I'm going to quickly do is, I'll tell you what I can do, is let me get the slide that's missing. I think it's missing here. Let me pause there for a second while I'll make sure that this slide is up. I'm going to hold it up there like that, okay? So we've gone through, I'm going to make sure that slide's up later. I'm going to read out the numbers. It doesn't really matter at this stage. But the principle is that the Passive House standard is for new buildings, not necessarily houses. It could be any building, a shopping center. I was in Munich when we went to a shopping center that was Passive House. For new buildings, houses, obviously, schools, nursing homes, all new buildings. The NFIT standard is for existing buildings. So you're trying to get close to the Passive House standard, but they give you a little bit of leeway with it. That, for example, the heating demand for a Passive House standard is, I should ask you what this is. You should know it's 15 kilowatts per hour per meter squared per annum. The NFIT standard gives you a little bit of room and leeway on that, and it's maximum of 25 kilowatt hours. You've got an extra 10 to play with, and they don't have to worry about the heat load of, you know, the minimum. When it gets to a very, very cold day, it doesn't matter. The heat load is irrelevant. The frequency of overheating is the same at 10%. The air tightness, they give you a little bit of leeway on that you are able to have on a Passive House 0.6 air changes or better. And on NFIT, you have 1.0 air changes, so you're a little bit there. The non-renewable primary energy is the same at 120, and there's a load of other stuff there. I'll make sure that slides up too, but that's the Passive House standard. So this was in his book as well. It's similar to the one that I showed earlier from the Scottish book. That it shows the modern building where you have waterproof cavity walls, well-sealed windows and insulation. And this is a traditional building where you have heritage windows and moisture moving through. And you need to make sure that water vapor is absorbed and evaporates in this building. That's why you can see a capillary water coming up here. You need to ventilate in that floor. And he's got that as heritage pre-1919. So on an existing building, you could, if it's like a white rendered building, you wouldn't do it with a traditional brick building or stone. You could have external insulation. Here is EPS insulation that's rendered with a monocouche render, 250 mil. You could then have on top of the, see what have you got here? Mineral wool, 100 mil between the existing rafters, and then over, so you take the roof finish off and then replace it with 150 mil of insulation on top of the rafters. So we're not looking at heritage buildings where the slates are like protected and shouldn't be touched. So you wouldn't do this on a protected structure, but on a house that is not protected, where you are able to take the slates off, you could do this where you could externally insulate on top of the rafters and then replace the slates on top of that. So this is a typical section showing that insulation. So earlier I said that I'd like to see an axiometric. What I'd also like to see, like we did in semester one, I'd like to see a full section through the building that shows your air tightness procedures and your insulation procedures for a new, if it's a new building or if it's an existing building, what you're doing. This second slide, so these are ones I pulled out from this book. So rather than you buy the book, I pulled it out, I took some photographs of the pages, and basically just pulled out some sections for you. So again, I think I'm missing a slide here too. So this, yeah, I'm missing a slide here. So I need to pull this one in. Basically, this is the existing drawing, the existing build-up of a existing roof where you've got this wall, and what we're going to do is the same thing where we're going to insulate up the wall and then insulate over the top of the roof and make the insulation continuous effectively between the wall and the roof. I'll make sure that that slide gets updated that includes that that continuous insulation across that. I might be able to find it here and show it to you to make sure that you have it online. I'll make sure it goes up. Hold on, bear with me a second, let's see if I can find it. Bear with me. It's good case studies, isn't it? So if you're into traditional, like older buildings and you want to insulate them, this does go through a lot of details with it. So bear with me, lots of case studies. Here we go, here it is, here it is. So, there we go. Top image is the existing existing build-up of the roof. That is existing rafters, roof felt with a sort of with the fascia here, and there's the wall, and there's the roof coming in. What you then do is you make sure that you extend the rafters over. When you take, see, the rafters need to extend. So the second image shows the extension here of the rafter depth. So there's your roof rafter going across with your insulation there on top of the rafter. And then you have a gap here to show the, to allow for the third image that allows the insulation to be externally insulated up the wall. So there's your external insulation, there's the roof insulation, and what you have is continuity across to make sure that that is continuous. So in your sections, what I'm looking for are continuity of insulation. We don't want any cold bridges. So that's what that's doing, is making sure that the insulation is continuous. That's at the roof level, at the top of the roof level. Down at the floor level, if it is a concrete floor, you're going to find it very difficult to insulate that, because unless you take all of the concrete up, dig down, which is what we do a lot on cottages, we take all of that floor out and redo it. This is about as much insulation as you can get on a traditional floor. If it was a new build, you'd have 150 mil here or 200 even, of floor insulation. On cottages that we work on, we take all that floor up, we dig it all up, and then we relay it with new insulation. If it's a timber floor, remembering back on what we did before, we would need to make, you can insulate between the rafters, but you also need to make sure that what you have is ventilation underneath that floor to make sure that the timber is still ventilated. So this is a similar example. There's the one with a concrete floor, and this is the one with a timber floor where you've got insulation, the floor finish, insulation with a new block here. So it's raised a bit, so you might need to readjust the door heads and the doors. And this is insulation in the between the rafters. Sorry, the floor joists. That's down at foundation level. You then have, above that, you have a, on the roof level, you're trying to have continuous insulation again between the walls and the floor. So again, you could have it externally insulated The other diagram that I showed you, the larger section shows that better here. That's a much better detail where you've got the roof coming down and the wall coming down. So, not all of these things can be done in one go. You might be able to do external insulation. But if you're doing the external insulation, it's a good idea to do the windows at the same time. So these are the savings that you can get in a stage-by-stage basis, and what the energy demand is through those stages. If it might be difficult to read, where if you changed the windows and looked at the ventilation, you could have 26% energy demand savings. If you did the basement ceiling and the roof, it drops down to 53% savings. If you do the exterior insulation and the entrance door, it drops right down. That exterior insulation is really important thing. Exterior wall and the entrance door, it drops to 94%. And the heat pump and the solar thermal pump is also going to give you 94% savings as well. So, remember I showed you Vectorworks before? You could, as well as a new build, you could use Vectorworks to do the energy modeling of an existing building. This is an example of SketchUp using Design PH, where you will be able to model the building in SketchUp and then work out the heat balance of an existing building. And I think that is all. I'm going to stop the share of that and come back to you all now. And I'm going to unmute you all. You are all now unmuted so I can hear you. That is the context of what I would like to present today on existing buildings, where we went through some of the important parts about ventilation of old buildings, all the stuff relating to details, cracking, and then the NFIT standard. So what I would like to get feedback on now is, how are you getting on with your design project with Michael and Bernie? They are, to give you information that Bernie gave to me, that she and Michael are going to help you next Tuesday with that on the 31st of March. How are you all getting on with your design project? You can put it in the chat if you like, rather than talk. Anybody want to say anything about the project? Put it in the chat if you like, rather than talk. I'm taking it's not going that well then by the silence. Oh, hang on, I've got unmute all. Sorry, unmute. No, I pressed the wrong button. Unmute all. That's it. Yeah. No. Okay, we just got the brief last night to starting to work on the next stage now. We haven't got much of a brief to work on yet. So, it's not good. So, you haven't really done any design yet, have you? So no design, so no design done yet. Right. Okay, starting sketch design. I think next Tuesday, Bernie and Michael will be giving guidance. So it's good. It makes it very. It's really makes it very. It's really difficult because if you're only starting sketch design, then next Thursday, what I might do is, because next Thursday is the last lecture before we break up for Easter. So what about, obviously you're going then to be working on, your sketch design over Easter. So next Thursday, why don't I go through what I'd be looking for that project in terms of BST requirements and get some really good references for you for the types of drawings that I'd be looking for BST submission. That is what I mentioned during this, was a really good axonometric, a really good section. And then what you're doing is through that section, pinpointing key details and working out those details. So next week I might go through and a lecture solely on really good references, where to get them, giving you some good ones, and then trying to help you with that. My advice also is, if you do get the opportunity to, whatever project needs to be done, like there may be like a 4 or 6 or 8 week project later, my advice would be to take it if you can. If you can do it, take it. I'm not gonna get you to do anything relating to what I've done on the BST. If these slides were of use to you in your sketch design, use them. I'm gonna sign off now until 2 p.m. where we're gonna work through the book that I wrote ages ago, and we're going to see how I'm going to update that book in relation to the COVID crisis. So I'm going to start signing off now till 2 p.m. Professional Studies. Any questions before signing off? Of any nature. Has anybody got any questions of any nature before I sign off until 2? All right. Well done, everybody. It's appreciated that you're coming to this, and I'm going to see you. I'm going to see you at 2 o'clock. All right. See you later, everybody. Take care.